This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Sieber. Good morning, Robert. Good morning, afternoon, evening to you, dear listener, wherever you are.
Good morning, Peter. Let's do a quick update. I still have a few things to prepare for our event next week, and you are on vacation. So a quick update.
No, I am mobily working.
Mobile working.
Things to share. So
okay,
but I'll keep them short if you want to. Shall I start?
I can start because yesterday I had really a depressing conversation. Yesterday I spoke to a mechanical engineer who told me, and now listen, we have burned ourselves on the topic of AI issues. Our customers no longer believe us when we say it works. I was surprised when I heard this. It's a mechanical engineer and they said they did so much when it comes to AI. They showed their customers so much, but now it doesn't run every time as well as they promised. Mm-hmm. And now the customers are frustrated and they do not believe anymore that it will run. Mm-hmm. So, we should think about that. We should maybe think about that, doing a episode about this topic, because I think there are more machine building companies, mechanical engineers outside with the same problems.
Sure, it's. I guess it's an issue, and I do want to talk about it, not directly today, but do talk about mechanical engineering in general, and making sure that we move towards determinism. That's what we're used to. That's what we need, and that's what we need to provide in the end. And you know that I'm working with Christian Gilking from Embraceable AI. He is moving in a direction where he's going to make sure that the engineer, and in also any other area where you need 100% deterministic, if I provide an input with the same variables, that I get 100% the same outcome. And I think there is potential, but listening to you talking to the mechanical engineer, those customers have not always received the solution that they needed.
Yeah, but the solution went very well in the lab, and when then used in the real world, it doesn't work. So yeah, it's a problem, and we should think about. But we already did an episode, I think, with Oliver Niggemann about robustness and AI, and maybe we should talk again to him. What is his opinion on robustness?
Yeah, sure. And in the end, it's what Boris Scharinger from Siemens has introduced a couple of years ago: industrial grade AI. Mm-hmm. It's exactly along the same lines towards 100% robustness, towards, or in the end, 100% deterministic. So I think we're going to be able to keep the Gen AI, and we should talk, of course, to Jakub about this topic as well. When we see him next week at our conference, he is, Mr. Gen AI, and keep that capability of the human, I would almost say like human style interface, but then the back end, whatever it's going to be doing for us, we need to make sure it's going to be deterministic.
Absolutely. So what else do you have, Peter? What is happening in your van?
We're going to cut that out. Oh, sorry.
No, life is life.
Life is life. Yeah, keep it like this before I can give an answer. Let me see. As long as this is okay, I'll continue like this.
It's okay. Go ahead.
Yeah, so the NXAI guys, you know them. They have a new paper. It's called XLSTM Scaling Laws. Competitive performance with linear time complexity. There's Maximilian Beck, Kajetan Schweighofer, Sebastian Böck, Sebastian Lehner, and our good old friend Sepp Hochreiter. Now, they say scaling laws always play a role in the success of large language models. While transformers have been the dominant architecture, there's others like, as the one we know, XLSTM, and they conduct a comparative investigation. Now, the findings, I'm going to come right to the point, reveal that in typical LLM training and inference scenarios, XLSTM scales favorably compared to transformers. And very important, XLSTM advantage widens as the training and inference context grows. Now, my take, at my level that I can understand it better and cheaper, right? And I said on LinkedIn, I get that. How about you, Sam? You can imagine what Sam I mean. And if not, I said that means if you are smart by applying XLSTM rather than transformers, you may only need one data center providing the energy similar to the energy need of Switzerland or Portugal or New York City, not 2 or 3.
Mm-hmm. Exactly.
I haven't heard from Sam back yet.
No, me too. But okay. I'm biased. But I think what I can say is everybody's doing this scaling laws papers. The big guys, the OpenAIs, the Apple guys are doing this scaling laws, and it's very impressive paper because they really used and run the model on the GPUs, and they spent a lot of flops in this, and it's very impressive results. And then there was one note or one quote by Kaitan, and I think this is really interesting because it's a huge deal for future agentic systems that need to operate over long horizons while staying affordable. So that's the deal, right? So if you have long horizons and long context, then it's cheaper and better to use the scaling law said that use an XLSTM instead of a transformer.
And I looked at it. There was a log file similar to the log file that we know from the other huge law from Moore. It's a log file. And when I was looking at the numbers correctly, but that's, the guys need to share with us. I was looking at maybe like a tens or 100. So I was looking at 2 dashes on the log file, so up to 100. So if there's a small difference, well, who cares? If there is a structural difference, which there seems to be, sure, everybody's going to be interested in. The other thing I thought about was the bitter lesson by Rich Sutton. We all know, we talked about, you recall, dear listener, March 13, that was 2019. And he says, seeking an improvement that makes a difference in the shorter term, researchers seek to leverage their human knowledge of the domain. But the only thing that matters in the long run is leveraging computation. Now, is that still true or wrong? Because what Maximilian, Cayetan, Sebastian, and Zeb, what they have done is knowledge, right?
Exactly.
So I think we can now, and in the meantime, others have questioned, of course, and that's the opening of the paper, still power is important, but I think this also shows that the bitter lesson has an end. So humans with their brains making very smart algorithms do make a difference.
I think it was in February this year, Sepp wrote an article for the German Frankfurter Allgemeine Zeitung. Right. That's a big German newspaper, and he said the bitter lesson is over.
Oh, so that's what he already said. Okay.
Yep.
Okay.
Yeah.
I didn't know that. That's what we agreed on.
Exactly. And this is the same idea you mentioned. Yep.
Okay, very good. Let's move on. You have one. I still have a couple of ones.
Yeah, I can a little bit spoil something. There will be, in autumn, you will see more, and it's not a paper. You can play around with something. So let's wait for a few months. Yep.
Looking forward to. I have another one. This is a very uncomfortable truth, but that's who I am. Now, it's about data science democratized. It's a piece by Paolo Perrone. He shows a tombstone. Maybe you saw it. Rest in peace, Webmaster 93, 2005.
Yes, I saw that.
Flash developer 96, 2011, and then he puts the data scientist there. I'm just going to share what he put up there, right? 2012, 2025, because I do believe that we should not close our eyes. And we're not saying if that means rest in peace data scientists. We need to discuss this. I really do believe so. He says traditional data science workflow 2020 was clean data 2 days, build the features 3 days, train the model 1 day, create visualization 2 days, present findings 1 day. The new workflow 2025, you make a prompt, perform comprehensive and advanced data quality analysis. Now,
I'm skeptical.
You already shared in your opening statement that this does not always work, right? I mean, it doesn't work in mechanical engineering. And of course, it does not work 100% within the data science area. Now, still, he says the death blow came from 3 directions. AutoML killed the modeling, LLMs killed the analysis, and no-code tools killed the pipelines. So I'm not going to go further in detail with this one. He says the only thing you need is English, or, of course, German, Spanish, Italian, wherever you are. He says the smartest data scientists he knows already pivoted. They are building the AI that's replacing them. Now, it's along the same lines of your opening statement. This cannot be 100% true, especially not today. But I must say the direction that we're seeing here is maybe something we need to be looking at. And I do say so because especially I am part of the conference, Machine Learning Week, November 17, 18 in Berlin. There's loads of data scientists there. You should be there. And if you haven't considered, please consider joining us there. And I do expect, and I'm looking forward very, very, very much. I actually, 2 years ago, I did like a session on the very topic. At that time, everybody was like, oh no, this is not going to happen to me and stuff like that. But I do really believe that we need to discuss how the people that are still studying data science, with the people that call themselves a data scientist for 10 or 15 years, how they are dealing with the tools. That is the thing. And I'm going to finish this off with sharing with you. And that's 30 years ago. I was a young guy, yes, at Intel, this company who is struggling these days. It was not at the moment. And I, together with another guy, I came up with this thing we called interactive. In the end, that was all the internet activities. And I was put together, two in a box, that was an Intel term, with a senior manager who had been managing around 30 employees, and they were doing literature, printed literature. And our job was to put everything on the internet within a year. Now, that's 30 years ago. Are we going to see a similar thing along the lines of what we were hearing here? Sure we are. And we are in a difficult situation, maybe, as per your opening statement, Robert, but that does not mean that we're moving a certain direction, right?
Yeah, it's interesting because I did an interview with Gabriel Krummenacher. Maybe you remember Gabriel. Sure. Yeah, he's a head of data science at Züge. And we talked about a survey they did with a lot of industrial companies. And he said that agentic project or agentic approaches are only successful or are more successful if you have a good data science team in the back to handle these agentic processes. And he said, so at the end, agentic approach is a data science project. It's still a data science project and for the data science team. And this is an interesting thought. I recorded a whole episode with him about this topic, but I think this is exactly the opposite to you, right?
Yeah, there you go. And that's the kind of discussion that we need. And that's the one I'm looking forward to having. I want to share one piece, no podcast episode without agentic. You just brought it up and you did one we're going to be listening to. Now, there was Andreas Horn from IBM. He referred to Deloitte release a new framework, agentic. Now, the only thing I wanted to share was my latest thinking. And I talked about the copy of me, the copy of X. So I referred to the past human travel agent. Now, by the way, there's another example of a job that does not exist today, right? Or does it still exist? Maybe. There's very few people who sit somewhere on a desk, and probably more the older generation can go to them and say, I want to go somewhere. No, it will suggest book a holiday based on my personal requirements, right? And that's reasoning, creating value. That's what the Deloitte was saying. For me, rather than spending many, many hours looking for the weather forecast, camp resorts, direct access to the sea, whatever my agent will make a proposal within minutes, right? Now, and the better so my agent will get to know me, then there's going to be feedback loops. The better the proposal is going to be. And it's going to be reducing these hours-long conversations between me and my traveling partner as well, right? Now, with the travel agent, I call it a copy of me. Because normally I, as a human, I would be thinking about what do I want to do? I talk to my partner, where do you want to go, et cetera, et cetera. But let's give an example very far away. If I say a copy of X example could be, an agent running a plant, interconnecting with thousands of copy of X agents, as I call them. And this is still thinking under development, so to say, right? So along the lines of the above workflow criteria, it's further away from me, but in the end, it supports a copy of me. If I am the plant manager. Let's say I'm the plant manager. Theoretically, I could be what you say holiday. I'm not on holiday. I'm working from somewhere else. And I think in the end, and that's maybe back to Gabriel, the human in the loop concept will exist for many years. Now, are we going to have 100 humans in case of a nuclear plant? Yes, very possible. Maybe instead of 1,000, I don't know. And in other cases, maybe there's only going to be one human, where maybe in the past we had 5 or 20 or 100.
Mm-hmm. Okay. What else, Peter?
Oh, yeah, I still have 2 more, if I may.
Okay. Yeah, sure.
Okay. What was the more? Dirk Molitor. Yeah, I think I'm going to be doing an interview with him soon. We'll talk about that later. And he shares an impressive graphic. I think it's the V waterfall classic model.
I saw that. Very complicated.
It's a huge.
Yeah.
In the end, I'm not going to go into that details. Maybe I will do that with him in the interview. Where do you see the greatest potential for AI in the product development process? Now, I say and I'm not sure that I gave a sensible answer. But nevertheless, the first thought that came to my brain is some kind of engineering democratization now. And I will come back to your opening statement. If it's not working, if we're stumbling at the moment with providing AI solutions for the engineer, then what I'm saying here, every consumer will be able to develop their product. That's not going to happen today and not tomorrow. But I do believe it's going to happen nevertheless at some point in time. 2 things on Munich. In Munich, there's a company called Augmented Industries. I hadn't heard of them. They raised 4.5 million. Yes, the numbers in Europe are always a bit smaller, where there's billion or trillion in the US. We're still millions. Nevertheless, they say current training and knowledge tools, they don't meet the needs of operators, technicians. In operations, it's about getting things done with quality, safety, and efficiency. And with Flow Tool is how they call it. They bridge the gap between qualification and troubleshooting. So that says Elisa Roth. She's the co-founder, CEO. Maybe I should send her an invitation to
Absolutely
to learn more.
Yeah, very good. I'm looking forward.
I have one more.
Yeah, go ahead, Peter.
If I may.
Yeah. You are not on vacation. You are right. Yes.
Yeah, well, no, it's actually about our Oktoberfest. Many people from around the world have heard of the Oktoberfest. And I spend most of the time. I didn't spend the last couple of days for specific reasons. But yeah, it was closed a couple of times. There was a bomb threat one time. It had nothing to do directly with Oktoberfest. But there was also overfilling. And the responsible folks have announced that they consider doing the entrance counting with AI next time. So what did I think of? Who did I think of? Do you recall a person who was doing that in the past?
No. Who did this?
Christopher Schäuble.
Remember
Schäuble. Christopher.
Yeah, but he's now in a different field. He's now in the field of ESG, right? So I think
you're right, because I wrote to Christopher. I haven't heard back from him yet. I looked at our Excel, and what Robert and I typically do after our news section, we look at our overview, what is coming in the next couple of weeks. And I go back to 2019. Christopher was our very, very first guest. He was guest number 1.
No, he was not guest. He was really,
you, dear listener, and to us as well. Now, the point here is nevertheless being, if it's not Christopher, as you say, who's doing this today, he was with Framos, I think Unterhaching, close to Munich, today CubeMOS. Yeah. He hasn't answered yet, but if you, dear listener, may be able to provide a visitor calculating solution for the 2026 Munich Oktoberfest, let me know. I'm happy to pass on to the responsible persons.
Perfect, Peter. So you're heavily involved in the Oktoberfest, right?
Not heavily. We, with our Bavarian band, we do play every now and then, and I do have one or the other connection into the organizing committee, yes.
The Dutch Peter is organizing the Oktoberfest AI.
No. Do you still have one? If not, I have a closing one.
Yeah, you have a closing one. Perfect.
Jonathan Slotkin, he's a chief medical officer. Oh, why is Peter talking about chief medical? As a neurosurgeon, he says he cares a lot about road safety. And he talks about Wino, stunning safety results, 91% fewer serious crashes, 95% fewer injury incidents than human drivers in the same locations. He says, if every US vehicle performed like Waymo, we'd prevent 33 to 39,000 deaths annually and save around 1 trillion in societal cost. And then I do that many times, and I've done it before. You've seen it probably. What I copy is then a quote from the story called Sally by Asimov, 1953. And Asimov says, we take it for granted now, but I remember when the first laws came out forcing the old machines off the highways, limiting travel to automatics. He calls it automatics in 1953. Lord, what a fuss. They called it everything from communism to fascism, but it emptied the highways and stopped the killing. And still more people get around more easily the new way. So it's so impressive, right? What I say, the name of my company is Asimov Vero, is a play on words. It's a play on words. It deals with Asimov science fiction prophecies to come true like the Italian word vero, right?
Peter.
I really guess this is the first prophecy by Asimov to come true, and I do believe there's going to be many to follow.
Perfect. So let's come back to the shop floor. And because in the main part, the guys from Path Robotics are waiting, and it's a startup founded in the US, and they raised a lot of money, 200 million or something, really impressive results. And I did the interview with the CEO on his solution, and I'm really looking forward to meet you next week at AI in the Forest, Peter, to discuss the latest and greatest with Jakob Marco about new industrial AI use cases, Gen AI systems. Looking forward to some newbies at our event. And thanks again to the guys from SICK who will host us this time in Waldkirch.
Thanks, Robert. Looking forward to see you too. Thank you, dear listener, having stayed with us, and looking forward to have you with us again very soon.
Bye-bye.
Bye-bye.
Hello, everybody. My name is Robert Weber, and my guest today is Andy from the USA, one of the founders of Path Robotics. Welcome to the podcast.
Hey, thank you guys so much. Really excited to be here.
Yeah, you are welcome. Please, Andy, before we start, please introduce yourself briefly to the listeners.
Of course. Yeah, I'm Andy. I'm the co-founder and CEO of Path Robotics. Started this company while I was doing my PhD. My PhD focused on deep reinforcement learning for humanoid robotics, and worked on that about 10 years ago.
And you are based in Ohio, right?
Yeah, we're based in Columbus, Ohio.
So it's not West Coast or something trending. It's the mainland.
Yeah, we're in the heartland.
Yeah.
We wanted to be really close to our customer base, and about most manufacturing, it really gets done in the middle of the country.
Okay. You have raised a lot of money in the last months, 100 million in Series D. What do the investors see?
Yeah, so we have raised a lot of money. A lot of that money is continuing to go to our R&D efforts. What we think about and what our investors think about a lot is, how do we continue to build this AI? How do we continue to build this physical intelligence for manufacturing? It's still a massive gap in the market right now. You really have two dichotomies. You've got traditional robotics that are using PLCs and hand programming, and then you've got academics that are really just focusing on pushing the bleeding edge of technology. We'd like to sit in between, where we're really utilizing that capital to push the bleeding edge, but do it with what's actually been out for the past couple of years, so that we can really start to see changes and growth in these models, and so that we can see these changes in growth for our customers.
So, but you focused the welding market, right?
Yeah, today we are focused on welding. So most of our customers, they do a lot of heavy deposition welding. There's three major verticals for us. There's energy, there's data centers and AI, and there's defense. Those are the three large verticals that we go after. And again, most of this is welding, but that's just where we're starting. It's not where we're going to be ending.
Mm-hmm. We are called industrial AI. Let's talk a little more about your AI-driven approach when it comes to welding and your robot. Inform myself a little bit. The robot scans the workplace and it creates a 3D model of it. And then the system automatically recognizes the shape and the position of the relevant weld seams area. How do you do that? Can you please go a little bit deeper?
Yeah, so that's exactly what happens. So yeah, we build a custom sensor that lives at the end of the robot. That sensor is taking in 3D data.
Is it a vision sensor? What kind of sensor is that?
Yeah, so that sensor has vision capabilities. So it takes in 3D data, it takes in 2D data, so from cameras. It can also take in sound and a couple additional inputs as well. And we take all of that data and then we pass it basically through our large neural network, our neural network that we call Obsidian 1. This is a model that we've been working on for the past 7 years. It's a model that then once you give it all those inputs and you bound it with saying, here is my WPS or the boundary box of what I need, what I can do on the actual welding side. It then takes all that information and then it creates everything past that. How to weld, where to weld, what parameters to utilize to get the ideal shape. But it's able to do that also with the inputs constantly varying. So one of the biggest issues in welding for the long time has been that there's a lot of variability and you have to be within plus or minus a millimeter. And you have to be able to adjust and adapt your heat based on what variance you have. And so our neural network is able to adjust all of those parameters on anything that it sees. So it could have wild variation, not just in location, but also in gaps and tacks and other things that cause a lot of heat change.
But how do you do that with a model? What kind of model is that?
Yeah, so I mean, the model overall, I mean, the best way to say it would be we kind of do imitation learning to get a policy network. And then we have about 7 years of data that we've collected, and we made a world model out of it. So if you guys know what world models are, they're basically neural simulators. So we've created a neural simulator that represents the physics of welding better than any analytical algorithm on the planet. It's basically because, again, we've got tens of millions of welds where we're actually collecting data looking directly at the weld. We use that data to then create this neural simulator. We use imitation learning to get a first policy, but then we actually refine and fine tune that policy with reinforcement learning in the neural simulator.
Okay, that was my question next. Okay,
and then at the end, we have it's basically just a large neural network that executes on it. So it can, again, the network inputs can take 3D and 2D and a couple other features, and then it literally outputs essentially waypoints and trajectories and welding parameters for all of it.
I want to come back to your sensor because you mentioned there's a capability for vision, but also for sound. Why sound?
Yeah, so sound's an interesting metric. It's really powerful in welding. There's a lot of human welders that say...
But it's a little bit underestimated, right?
Oh, it's very underestimated. Yes, correct. Yeah, sounds really interesting. So if you talk to human welders, a lot of them will say that they can tell where to weld based on what they're hearing. And it's not something that a lot of people think about in our space, in the robotic space. A lot of people think, I need a camera, I need a 3D map, I need to very logically build out this entire thing so the system can see it. But no, sound is it's a unique input, but it's an input that's really valuable for understanding not just, potentially where you should weld, but really how you are welding in the moment. And it gives good key insight if we think we are starting to weld inaccurately, if we think we're starting to potentially have a bad weld. It's a really key input.
At this point, we will make a brief comment as Andy's colleague has provided us with further information. Quote, at a high level, Obsidian processes these varied data modalities through a modular architecture that respects their unique structures while enabling unified reasoning. Modality-specific tokenization and pre-processing. Each input type is first converted into a format the model can understand. These are discrete tokens or embeddings that capture essential features. This avoids forcing incompatible data like raw pixels or audio waveforms directly into the backbone. Obsidian can take sound, vision, as well as robot state and welder power supply. Adapter layers for alignment. Once tokenized, each modality passes through a lightweight adapter layer. You can think of these as small neural networks tailored to that input. These adapters bridge the gap between raw modality features and the model's shared representation space. In Obsidian, these layers ensure low latency processing, making it suitable for real-time robotics, fusion, and joint processing. Through these tokenization and adapter steps, all modalities are projected into a common embedding space. The core transformer model then processes them jointly. You mentioned 7 years of training or of data. How was the model trained? Who gave you this large amount of data? Is it scientific data or is it real world application data?
So it's all real world application data. So it's all collected from our systems that are in the field. So we currently collect data from every single robot that's in the field. Welding every single day.
But who gave you this data? Because from a European perspective, the companies are very skeptical when it comes to sharing data with some AI companies building big models. Who gave you the data?
Yeah, so all of our customers to date have signed over and signed that they allow us to collect data at their site every single day. It is data, so why are our customers okay with it? They're okay with it because it's data that's really just critical to our neural network learning. It's not data they're collecting anything proprietary about their product or proprietary about their design or anything that they would be really concerned about, having their competitors understand. It's literally all the data we talked about, 3D, 2D data, looking directly at the puddle, looking at the part, looking at the fit up. That's the data that we collect. And we collect it basically at our customer site every day while we're welding.
Mm-hmm. And I want to come back to the process when it comes to welding, because I already mentioned 3D model, then the system automatically recognizes shape, etc., etc. How do you achieve then real-time adaptation to this?
Yeah, so when we are welding, so we do an initial scan, we take that information, we put it through our network, we get our outward trajectories and our welding parameters. Then actually, while we are welding, we turn our cameras back on. And that's really where the sound is utilized. So sound is actually utilized purely on real-time execution, not on initial execution. We are then using, again, cameras, lasers, sound in real-time execution to make adjustments on the fly. And that's about like a 30 hertz update frequency.
Wow. How do you handle that? Is it handled by an industrial PC or by an edge device or GPU, or what kind of hardware do the customer need?
Yeah, so it's definitely an industrial PC. The PC lives with the system, like our cells. And it's about a stack of, depending on how many arms we're running, it's a stack of about 2 to 4 GPUs that basically really power this, so that we can do edge computing.
Mm-hmm. But when it comes to welding, there are different materials. So how do you generalize the model to different materials at the end?
It's a good question. It definitely is one of the harder problems by far, is to be able to get to a true normalization across the board, so that you can kind of go through, 4-5 wire, 5-2 wire on steel, stainless, etc. So, yeah, I mean, it is really kind of one of the more difficult pieces to really get to a single general network that works across all of the materials. So for us, not only can we, one of the ways that we obviously do it if necessary is through fine tuning. So, potentially taking the network and then fine tuning on a customer's material. And we have what we call as a data farm. So we have customer data that we collect at the field, basically every day. But then we also do data farm collection basically at our site on our customer's material to allow us to get an initial seed set of data to be able to either validate or fine-tune the network from there.
So the fine-tuning code is your secret sauce at the end?
Yeah, I would say that, but also just building and collecting all of this data. It's been a journey, and it's one of the most critical pieces is how do you get data at quantity, and then truly how do you have the right data to actually have something be functional. I mean, there's not a lot of people in the world. There's probably very few companies truly in the world that are using reinforcement learning to get a output policy network to drive an overall robot trajectory. So but then yes, like being able to move from material, that is also like a critical piece of how to accelerate and really make this be something that can go live versus pure imitation learning and fine tuning on a per customer basis is still like in its infancy and hasn't really been able to be figured out how to be scaled to actual customers yet.
Absolutely. And when it comes to materials, that's one thing. And the next step is now different robots. But I think that's not the big problem, right? So you can work with any robot in the market, or how do you handle this?
Yeah, so we're robot agnostic. There's 2 robot brands that we mainly deploy, which is Yaskawa and Universal. But there isn't a limitation for us. We've got great partners in the 2 of those companies, and we haven't really found a reason why we need to change. But yeah, the stack overall is essentially agnostic. There's a driver that we create that connects to the robot package, and we can do that for your ABB and KUKA and FANUC as well, if needed.
Okay. Your main focus is the model, or are you building an operating system at the end for welding robots? What is your goal?
The main focus is the model.
Okay. So you want to sell the model then to the Yaskawa guys as a part of their operating system, or is it sold to welding customers of Yaskawa? So what is the business model behind that?
Yeah, so the core technology that we build is really on the model side, or models, right? It's the sensor and the model together. So it's the perception and model. That's really the core technology that gives the large differentiation. The actual business model, though, is robots as a service. So even though those are the 2 pieces that really give core differentiation in the product for our customer, we still have an operating system that we are building for robotics called Path OS.
Okay.
Essentially, it's
that's the operating system. Okay.
That really powers the entire system so that we can give our customers still turnkey products. And so we do full stack essentially today. But if you really think about like what we want to build long term, that's the key differentiating elements. It's the perception and model at the end.
At the end, the success of a model depends on how reliable the model is. What about the reliability of the model? How accurate is the model? How robust is the model?
Yeah, it kind of, again, in any situation, it's as robust as the data you have to some extent. So again, it's taken us a while. So like, this hasn't been a year of data collection. We've been really doing it for about 7 years, really trying to get the data to we need and continuing to expand the bounds of the data so that we have, most things that we'd see in real life would be within our data set or something close. But the big difference here for us as well is when we move to the world model and we use our current data to create the world model, and then we used reinforcement learning inside the world model, it allows us to get to a finer, it allows us to kind of get to, kind of not necessarily edge cases that are out of distribution, but allows you to smooth the entire network response to be more densely packed inside your distribution. Which has really helped on the reliability side, really helped on the consistency side, I would say. So right now, how we define the overall system utility would be by first pass yield. That's the end piece, right? Is like not just how does the model respond, but then how does the model respond to the entire stack? And then what's the end output for our customers? So the way we look at it is we're about at 98% first pass yield. So about 98% of the time, there is no failure at all, no little failure. It is 100% pass on the weld. And that's what, heavy deposition, structural welding. So that's kind of how we grade the overall process and the progress. And the goal for us is obviously to keep going from 98 to 99 to 99.5, 99.9, et cetera, et cetera, et cetera. That's really kind of how we look at the consistency of it.
Let's think about a customer, mid-size company, and he wants or she wants to deploy now the model to his or her welding solution. How difficult is it to run the model at the end?
So nobody can run the model at the so we only give turnkey solutions today. So,
is it not an option to sell the model by itself?
No, we do not sell the model by itself. No, it's robots as a service. You have to buy the welding robot.
But it's not an option to do that, to sell the model.
Yeah, it's correct. It's not an option to do that today.
So it's a combination of hardware and the model at the end you sell.
Yep, exactly. Yeah, we sell the whole thing.
Okay, that's great. Where are your markets now? We are based in Europe. We are from Germany. Siemens is our partner, and it's funny because we got a lot of interest from US companies to talk to us, and we have the same situation that all our German or European companies want to get into touch with US podcasts or US media because they see that the new big market is establishing in the US. Where are your markets?
Yeah, so we're currently delivered in all of North America. So we're in Canada, we're in the US, and we're in Mexico. And again, the three kind of big ones for us, and maybe fourth, energy, infrastructure, AI data centers, defense, and then, of course, kind of automotive and transportation. So those are the four big verticals. We're currently in all of North America. Most likely for us next, we will be looking to expand globally, looking at it more intensely and specifically in 2026. We're looking at Japan and Asia, as well as we're looking at starting in Germany and Europe.
Oh, that's interesting because defense is a growing market in Germany in the moment. So everybody's focusing on defense in the moment.
Yeah, there's a lot of it. The big spotlight going on in defense feels like in Germany, in the US, and a lot of other places right now. So yeah, there's a lot of opportunity in that space.
What about competition? What sets you apart from competitors in the welding market with welding robots? You have ABB, turnkey solution for welding. What sets you apart? Is it only the AI, or what is your unique selling point at the end?
Yeah, the big unique selling point at the end is the adaptability. So welding robots have been around for 50 years. And I'm at a trade show right now, and it's a sea of welding robots. There's probably 1,000 companies here with welding robots. But when you really look at the utilization and the adoption rate for robots, especially welding robots over 50 years, it's pretty low still. Really, it's only been about 20% market penetration over 50 years. And the reason isn't because the hardware doesn't exist or the hardware breaks or it's not robust. The reason has always been that the systems are not intelligent enough to do what the actual human welder does. And they're not able to do it at consistency and speed and reliability. And that's a big, big delta. So for us, we really are the only ones that actually offer true adaptive welding. Welding where it doesn't matter what the fit up is. It doesn't matter what the part is. We can see it and we can understand it and we can make changes to truly weld it. That is really the big differentiation. And again, it goes back to you want to be able to have a robot actually operate like a human welder. Like that's the end state, and that's the goal that a lot of these manufacturers want. They're sold something like that, and then they normally get something very different when they're buying an industrial robot from any of the groups. We're the only ones really able to give them that. Here's the robot, put the part in front, hit go, and let it go to work. And that's a huge, huge delta there. And then for us, after doing this on welding, we are expanding past it. And so, right, welding is the heartbeat of the company. It's the core competency of the company. But we are going into different embodiments on the hardware side, as well as going to different tasks along the manufacturing process.
You mentioned at the beginning you want to spend the most of the 100 million euros in R&D topics. What is on your tech agenda? Because you have a existing model. Do you need to train a bigger model, a more specialized model? What is the idea?
Yeah, I mean, so we're constantly training. So we're constantly continuing to collect data. Right? We're at 98% first pass yield. We want to get far past that. We want to get to 99.9999. We want to be able to have a single neural network that represents 1,000 or 10,000 years of human experience, basically, and be able to get to that first pass yield that is nearly perfect. So that's what we're going to continue to push on in welding, is expanding data, continuing to refine how we're training our neural network, continuing to refine and try different practices and try different models to try to continue to increase and improve the overall output. So we're always going to invest in that. That will be an always and forever thing that we invest in to keep moving that. But where the other money is going into is then, again, like the two axes that you can think about is embodiments. So different ways that we embody the intelligence in robots, and then other tasks. So welding is just one task done in manufacturing. the next big task that we're going after.
So you're already training a different model when it comes to robotics. Are you working on that?
Yeah. So we have Obsidian for welding. That's our model, our brand for welding. And then, right now we're working on what we call Epsilon, which is our model for dexterous assembly and manipulation.
Oh, that's interesting. How far you are now from publishing or from using this model?
So that's a good question. You're asking all hard questions. Yeah, so that's a really good question. The goal for us is we want to be deployed with this model and with this technology in 2026. And so we're working tirelessly around the clock on it. And again, it's the same paradigm of how we've done welding. Of start with imitation learning. Ideally, if you can, create a world model or potentially just create a higher resolution simulation for really contact rich surface. Like we're doing very contact rich, fine grain manipulation work, and then use reinforcement learning inside of that to really get to a global minimum that's actually usable in the real world. So we want to take the exact same paradigm that we've done on welding, and we want to do that on manipulation as well. So that's what we're working towards currently.
Andy, thanks a lot. I keep my fingers crossed for your ambitious plans when it comes to the welding model, when it comes to the Epsilon model. It was fascinating to talk to you. You need to add your head of AI to the podcast because we have one more question, how the model works. And I'm really looking forward to hear more in the next year. Thanks a lot and greetings to the US.
Great. Thank you so much for the time. Very much appreciate it.